Hi everyone, this is Sean Ismail from Cloud Ranger, and you are viewing the Microsoft Azure training. Today we are going to talk about the introduction to the cloud, and this is probably going to be the only video in this tutorial series where we are not going to have a demo. I'm not going to show you anything on Azure specifically. All the training videos in this series after this series will actually have a hands-on demo. This is just an introduction to the cloud today so we can set our bearings to understand the upcoming videos that are going to be part of this training series. So let's get started. So once upon a time, well, I'm just kidding. We're not going to go start into a history that way. The reason we are going to go into some history about the infrastructure in general is going to paint a picture of how things were before and why or how we got here today, and we even needed a cloud to start with. So for this, we need to know the history, and that's what we are trying to do now. So let's start with on-site systems and networks. A lot of you who have been in IT for a while will probably understand this right away. And even if you are new and you understand this, what we did before, you used to go to your work and used to have a room or a closet where you needed all your servers. So you'd have a server like a domain controller, you'd have a server like your file server, FTP server, web server. They all were housed on site, and you had physical access to these systems and these networks, routers and switches. Something like this. So you'd have a bunch of servers connected to a switch and a bunch of client computers connected to a switch, to a router, and to a firewall, which would basically be connected to your ISP. And we had this architecture or the way of doing things like this for a while. And it's very important to understand the term on-premise systems and networks, because that term will be very important in cloud to distinguish between what's on premises and what's not. But this is a picture of how we used to do things. Now, the problem with this was certain limitations. So you are at work, you have to provide your own electricity, something very fundamental like electricity, provide cooling, provide physical security access, provide internet connections. So you would have to actually subscribe to your ISP for internet. And those things came with certain limitations. For example, what happens if the power goes out? So you'd be like, okay, so if the power goes out, we'll need some sort of backup power. So we started getting all these APCs and all those systems to provide you some power. But for how long? So there were a bunch of assumptions that were taken that, hey, you know what, if the power goes out, we are going to be up for another 8 hours or so. After that, we are just basically going to go down. And this is a very, I wouldn't call small scale, but this was, you had to provide your own cooling. So can you imagine having, over here we have just 4 servers, but if you had like about 40 servers, well, to start with, you need the space to do so. And the next thing would be that you need that kind of cooling. So now you have to get this enormous cooling systems to ensure that your systems run optimum temperature, and you did not have any issues. And similar problems came through that, okay, what happens if the cooling systems break down? Now we are going to get some redundant cooling systems to address that. So you can get a picture of the complications or assumptions that you had to make to keep things on site or on premises. So a bunch of people got together and they said that we are going to create something called a data center. What data center essentially is it's a dedicated location where you would go and you'd have the space for housing your infrastructure. So as a company, you'd go there and be like, I need about 3 racks or 1 rack, or I need a cage, where I'm going to bring my own servers, my own infrastructure, that server systems, networks, and everything. I'm going to hook them up together. And the data center, that's what their business was. They were like, okay, this is a large space, thousands of feet, and what I'm going to do is I'm going to have a bunch of organizations come and do this, as in bunch of tenants. They'll come and do this. So it's a large space and you only need 3 racks. Somebody will come and say, I need 4 racks, and they would be all housed together. These data centers were designed to do something like this. So they would have a couple of amazing things. First of all, since they were in the business of providing this service, they would go and get connected with a high bandwidth internet provider upstream. So you could, for example, get significant amount of bandwidth and speed from these data centers, who would essentially become your ISP, which you'd probably not get by yourself if you're located on site. And the reason behind that is, well, they have more people, they have more tenants, they have more resources, maybe more money, and a legit reason to be connected to an upstream provider who would provide them that kind of service. All you were doing was tapping into their resources. And like you, many other organizations would do so under the same roof. They would have a bunch of things, like I said, they would be designed for certain things. So they would have a bunch of things that you'd ideally not spend so much time and money on your on-site environment, such as extremely redundant power source. So for example, if the power were to go down in a data center, they would have diesel generators, they would have they would have a lot of alternatives to ensure that you can run 365 days. And those would be uninterrupted services. So it's not like they would go down and plug something in. You'd not even know that something like that happened. It would also be dust-free controlled environment. So they would take care of those kind of things that you'd probably not even try to do on site, but is important to run your systems. They would have very efficient cooling and air ventilation systems to ensure all this infrastructure were running properly under the correct thresholds and limits. They would provide a lot of physical security, so you could just not walk into another organization's server and just tamper with and do whatever you want. And they would provide additional services like, for example, the same vendor could have multiple data centers, and these data centers could be connected together, and which is basically something like your disaster recovery or DR solutions. So there were a lot of benefits to move into a data center rather than keeping things on site. I mean, this was almost a no-brainer. So, which is fine. So we have moved from on-site to a data center where things are taken care of for us. And all we have to do is have our infrastructure in there. So you'd send a bunch of your guys, or you'd go in and design your own infrastructure, put your servers in it, install it yourself, run your software, do everything you want yourself. However, for certain organizations, even that didn't make sense. Smaller anyways, they were like, okay, so we don't have anything on site. We have it in a data center. Now we are going to provide our own infrastructure. However, I'm not that big of an organization. I probably just need 2 or 3 servers. I'm a startup company, and I don't have even resources to hire someone to run my one web server. I could not even justify the cost when I'm just a startup company. So data centers came up with another service, which were the managed services. So the way that works is that it lets data center manage the servers. So you go to a data center and say, hey, I need 2 servers that need to be up. They're going to be a web server and a database server to, for example, bring my company's website up. And the data center says, okay, don't worry about it. I'll get my guys to set up your servers. I'll make sure everything is installed. You can provide me the data. I'll take the data and put that in. It is still your website. You go get that designed, just give us the files and we will host it for you. And these servers are going to be yours. You can put whatever you want on the servers. You have RDP access or Telnet SSH access and do whatever you want. So essentially, they would host the server roles. And to connect to your office, we'll provide a LAN extension if required, which is basically a site-to-site connection if you need it. So people, if you are in your office, they should be able to connect to this server, or you should be able to connect to these servers and log in and do whatever you want, because you own this server now. It's hosted by us, but you own it and you can do whatever you want. But this hardware is ours. So anyways, there are all the benefits of a data center as well as the infrastructure administration. So you would not have to go, for example, and worry if a disk broke on the server, or you wanted to run some patches on the underlying hardware server. They would take care of all that for you. This is exactly when this managed services got really, really popular. And these were not, and I say that from my experience, were not exactly for smaller companies. These were for even large companies. These services got very popular with the rapid deployment capabilities. For example, you are a large company and you had a need for a specific amount of time, a lot more servers than you ideally want to purchase for a very specific task. So for example, you're running this entire marketing campaign and you know that this entire summer people are going to pound your web servers. So you'd call up your data center and say, can you put in for next 4 months 20 managed servers where you guys take care of the hardware, you guys purchase that, do whatever you guys need to. All I want is the capacity those servers will provide, and after 4 months, I don't need them. So the contract would be for those 4 months, and that is to happen quite often. So they got very popular, and what data centers started doing with this managed service is like they would just not do it for you. They would also do it for other customers, and these customers would come in and have similar requirements as you did, so they will all be hosted in the same data centers on their own servers, which was run by the data center. So essentially, they were called the tenants. So it's like tenant in an apartment building, like you are a tenant, you go stay in your apartment and that's yours, but the rest of the apartment complex had other tenants as well. So similarly in a data center, I mean, this was your server that they hosted for you, but these all other customers, they were tenants and they had their own space to do their own thing. So that's another term, tenant, which will be very important in this whole cloud training that we need to understand. So right after this, just when things were getting all warmed up and interesting, came the virtualization. This was very, very disruptive because it changed in doing things how we do today. So most of the servers coming from Dell, HP, IBM, all these companies, they had various models of servers of various capacities. So for example, you could go and say, I need a web server. They'd give you a certain CPU, certain RAM, certain everything else, and that's a certain model of the server. Then you go and say, hey, I need a database server. Your requirements changes. Okay, I need multi-cores, multi-CPUs, a lot of disk, and a lot of RAM to run my SQL server. So those would be a different model of a server. What was happening was that when you are running a web server and you have, and I'm trying to explain this in a very, very high level. So if users try to hit your web server, what would happen is it would create some load. If you have 100 users trying to get to your server, it will create some load, more load actually. And right after they're in the site is up and everything, the server would be idle. So for example, if your organization does not do anything during the night time, most of the users have to log into your site or get to your site or use your application during a certain amount of time, this server was running idle. So right after it did what it had to do, there's nothing much more for the server to do. So you were losing CPU cycles, all those RAM were just sitting there. So for example, your application needed 8 gigs of RAM, but you had about 16 in your server, those 8 would just sit there idle doing nothing. Once in a while, you would probably need to go more than 8 gigs of RAM because there was a load on the server, but the rest of the time it was doing nothing. Virtualization changed that. What virtualization did, it enabled multiple servers run on a single physical server. So we are starting to talk about shared resources. So think about this. You have one big server with a quad-core processor with about 64 gigs of RAM or 128 gigs of RAM, and you have a bunch of disk space. You can say, okay, I'll take this one server, and again, I'm making this very simple. I'm going to take this one server, I'm going to run my web server on it, and I'm going to run my SQL server on it. And the way I'm going to run it is not to install them on the same server space. What I'm going to do is I'm going to split the server in 2 proportions. And the way this would work is that as far as the web server is concerned and as far as the SQL server is concerned, they're all thinking they're running on their own physical servers. So it would look something like this. You had one large, for example, a Dell server, and you would have multiple servers virtually running on them who thought they were server themselves. So you'd actually, for example, in this image, have 5 servers run on one server, and these 5 servers would have their own operating system, and as far as the applications that were installed on those servers would actually think they're running on a physical server by themselves. So this was a virtual concept, and that's why we call it virtualization, and those 5 servers, they're called virtual machines. So this would be one big server, right? And you have these 5 virtual machines, for example, running on those, means the underlying physical server would have a lot of resources, but it never be very, very idle. It would always be busy doing something or the other because it's now technically running 5 servers. Virtualization changed everything. So all of a sudden you had this high capacity servers that used to sit idle, and you would utilize them to create virtual machines on them and run a lot of things. So rather than having 20 physical servers, you could get away with 5 big servers and have those 20 servers virtualized in them and have 4 servers each on them, for example, and you'd get away with that. It started saving costs, it started saving resources, things were easier to manage. You did not have to spec out and have that many admins take care of it. Virtualization became just very important, and as an administrator, a lot of people now take this as granted, but there were times when we had nothing to do with virtualization. This is important to know that the data center people, remember them, who used to provide all these managed services? They got an idea. They said, okay, so we are already in the business of providing managed services. So how about this? We run big hosts ourselves. What will happen if we can do that? So they started to get big servers and put them all together and say that rather than the customer coming in and asking us that I need one server to run a web server, what I'm going to do is I'm going to create a virtual machine for them, which would be one server. Which is interesting because all of a sudden now they could put so many tenants together at one place. They did not have the physical limitation or the cost limitations of buying one single server for one client or 10 servers from one client and just leave them like that. They could just make things more efficient and give the clients or the customers more options. How does that work? Well, you remember a couple of slides ago when we talked about managed services, we said that, hey, if you went there and said, I need a web server and I need a database server, they'd give you 2 servers. And you could go and say, okay, what are the prices on this? Well, the prices are dependent on the kind of workload you have and the kind of servers you want from them, right? So they'd be, okay, so I'll give you a server which has dual CPU for your web server and a quad CPU for your SQL server. Fine. And the limitation here is, what if the customer came and said, hey, you know what? I don't want even a dual core. I just want a single core server, single CPU server, and I'm okay with that. And the data center managed service provider says that, hey, we can't do that because we cannot go and purchase a single server for every single client. We go, for example, and buy 50 servers together, and the lowest denominator here would be a server with a dual core CPU. So you are stuck with a dual core CPU, you want it or not, and guess what? You're paying for it. So when this virtualization came through, what they started doing is that, well, we can give our clients and tenants more options. We can go and say, you know what? I'll give you a single CPU. I'll give you 4 gigs of RAM because now I can create a virtual machine with exactly those resources. And the other thing that came out of this were data centers now could have more and more tenants because not all customers required all those hefty specs on their server. And it's not only that, it's about density. So they could just put more clients on single servers and, get away with it because the customers would not even understand that they're actually sharing services as long as they were guaranteed a certain amount of resources on their systems. So what this resulted in was a very high density data center with lots of tenants who could all reside together and share resources and pay for what they want. Some of you might think this is very, it's understandable and seems very basic. That actually was not very basic because this changed how people or organizations started thinking of infrastructure as a service. They built a lot on this concept. So you could go to a website, for example, and order a server for yourself, and you are given bunch of wizards, for example, to actually configure exactly how you want that server to be with what resources. This changed how we did work because now rather than, and since whole virtualization is happening with the software, so think about it. You did not have to go call up the data center or the managed provider and be like, hey, I need a server. Can you install that for me? And they'd be like, okay, we'll get somebody to go rack the server, put that in, install the OS. Maybe they got efficient with time how they did that, but still it would require somebody to do this. Think about virtualization. If you have worked at all with virtualization, you understand how flexible it is. It's all happening through a software or a script at the back end, right? So all you had to do is pretty much create a web interface, which would give the tenant some flexibility on putting the resources he or she wants and pretty much click on go, and there'll be a bunch of scripts that are running in the back end on the virtualization system that would go and create the virtual machine for you and spin it for you and give you the information to connect to it without a person actually physically going and doing that. So this is the first time infrastructure was introduced as sort of like an utility model, that where you go and get whatever you want, use it for how long you want it, and you pay for what kind of resources you're looking for your particular server. So this is how things were. And when we are talking about this managed service in this slide, this was not a very long time ago. I remember doing this a few years ago, I don't know, 2006 or 2007, around that time. And we still do that today. For example, if any of you are Linux users, you are very, very familiar with VPS. VPS is nothing but exactly something like this. And VPS or these Linux systems, I feel came much sooner before Windows systems came in because I've seen the Windows servers being offered much later than the Linux ones. I could be wrong, but that's how I was introduced or I was familiar with the systems. So that's where the history ends. And now we are going to actually look into the cloud. So now you know how we moved into this model and how cloud fits in. So like I said, this was definitely more profit for the managed providers or data centers, whatever you call them. So next, moving on to the cloud. Cloud is an evolution of an existing technology. This is not really new, as surprising as it might be to a lot of people. Because if you remember from our past slide, we were sort of providing some cloud services. You could go in there, choose the kind of configuration you want, get your virtual machine up. So cloud is not new, or at least the paradigm has shifted a little bit, but it's not super new. It's an evolution, really. So the cloud offers broad range of solutions and services, right? So let's actually talk about this a little. Over the last couple of years, I've argued with a lot of my colleagues on what exactly is a cloud and how do you define a cloud? And we have always pondered and we thought that people are beginning to use the term very lightly. Not everything is cloud. Cloud computing has certain characteristics. So for example, these are just like litmus tests, right? You need to find out if a service provides this or has this characteristics, and you know it's a cloud service. First of all, it has to be self-service. So you should be able to go somewhere, a portal or a website, and do this yourself. If you have to pick up the phone and call somebody, that's probably not exactly a cloud thing. The resources are pulled across multiple customers. So this is again back to tenants. So a cloud should have the provision to have multiple tenants. So a lot of organizations should all be able to go in, and this underlying platform or this cloud thing should have resources all pulled together so they could give you some, they could give your another organization some, or another tenant could come and ask for something. Then there should be the term elasticity. Elasticity, it's again one of those terms that are very loosely used these days, but elasticity comes down to again that, the economies of scale. How do you, and these are benefits of clouds, right? I mean, how much more can you provide? What is the scale that you can get into? You can give more resources, you can shrink resources. So there is an elastic component as part of these characteristics. Cloud should be very reliable. This again comes down to basic reliability. So it should not be like one system in the cloud goes down and it takes you and other organizations down as well. Well, we could still argue about that with the things that have happened with Azure or Google or Amazon, where there were times where things went down a little bit, but basic reliability should be present there in a cloud system. And the next thing is it should have a model of utility services. So think of your hydro. So you probably have electricity at home. You have internet. Well, they're trying to now make internet utility. I'm sorry, I should probably not say internet. Electricity, water, and things like that. You are sort of paying that based on consumption. So if you're going to keep all your lights off, and you are gone out for a vacation for a month, you come back, your consumption is lower, so the electric bill is going to be much lower than if you were at home doing nothing for 30 days. So you are using more power. So it's like an utility. They basically send you a bill saying that, hey, you have used this many resources for this long, this is your bill. So it should have an utility model, and cloud, it's very important for cloud to have that flexibility where you go and do that. And these are the benefits of being in the cloud. So when we started this slide, I said this was an evolution of existing technology. I hope you can understand how this is so similar to our last slide, where they were just providing managed services with just regular virtualization. Because technically, we are doing the same thing in the cloud. These are virtual machines, these are virtual networks, these are virtual storage, all part of a pool which is shared and is given to you. Now, what is the difference then? The difference in cloud, at least from my perspective, when it's taken in contrast with the managed services of, yesteryears, where that now you have more flexibility in the resources you choose. So, for example, back then, you could go and obviously create a VM and provide it certain amount of resources. Now you can go into finer details of the resources that, okay, so now that you're creating a server, you need some more space or unlimited space sort of with your hard drive, and you need storage for your database, and you have more flexibility that were not present before. So things are almost similar, but now it's way more flexible. And just because it's way more flexible, you can pick and choose what you want, and that means you only pay for what you really, really want and do not pay for things that you don't need, which is a shift in paradigm from how managed host services were before. Now, if we understand cloud, I tried my best. Let's move into the categories of cloud services. This is going to be an interesting one because now some of you will understand what we really meant by evolution of existing technologies. Let's start with one cloud service, the SaaS, SaaS, which is software as a service, which is essentially means that software deployed over the internet. You know what? This is the first thing probably you'll notice that were there for a long time and absolutely part of the cloud and definitely not new. This has been around for a while. Web-based email services. If most of you, if not all, will have an Hotmail or a Gmail account. That's actually a SaaS. It's a software as a service. You do not have to have a server. You do not have to have a mail software like Exchange or whatever, SendMail installed. It's basically a service or a software you consume. So you basically go to a website, you log in, and you receive and send your emails without owning anything, not even the software. So SaaS has been around for a very, very long time. There are a lot of services like this, not only email, there are various softwares which you can consume online without owning underlying anything, let alone infrastructure. And this is a big part of cloud. Cloud has offerings, SaaS offerings. So the next one is a little different. PaaS, or platform as a service. It has similar benefits like SaaS. This is, well, the way I understand this anyways, is for rapid software development. So think about this. You are going to create a website and you say, hey, I'm a developer. I'm going to create a website and it's going to be data driven. So I need access to obviously a database. So what do you need for a database? You need a database server. So you first need to get a server, put your operating system on it, put or install your database software on it, SQL, MySQL, whatever. And then you are going to interface with that and you're going to have your website, which is essentially a web server connected to your database server. So if you are a developer, that's, as an organization, probably it's not a hard thing to do, but if you're a developer, that might be quite some work, quite some task, because now you have to maintain a server and software on it for running your database and essentially interfacing to that. What PaaS will do is basically say, don't worry about a web server, you don't need one. Don't worry about a SQL server, you don't need one. What we will do is provide you those as a service. So basically, you can get into a portal and be like, I need to create a database. They'll say, okay. So Do you need SQL or MySQL? What do you need? So, okay, I need SQL. So, okay, we'll give you a SQL database. How many databases you need and how big? And you say, okay, I need a database, well, I don't know, 50 gigs, and I need to interface this with my IIS website. So it gives you another portal where you go in and you pretty much create an IIS site. So technically, all you are responsible for in PaaS is your own code. It's hosted on IIS, it's hosted on SQL, and you do not have to worry about the underlying infrastructure that runs that, updates that. So, you don't have to take care of patches, updates, nothing. This is pretty good because now you can actually concentrate more on development than going and maintaining servers or virtual machines now because you really do not need to. Right, so PaaS is actually pretty interesting. It's good for rapid software deployments. You're not buying anything. You're not licensing anything. This is really, really good, and that's also part of your cloud services. And the next one is the most interesting one. It's IaaS, which is Infrastructure as a Service, and this is what we are going to do as part of this training series. We talk about the Azure IaaS, or Infrastructure as a Service, and we'll concentrate more on this. IaaS is same analogy if you think about it with your Hyper-V or VMware or Zen server or whatever virtualization platform you use. So you basically get a virtual server, you get virtual storage, network. It comes with operating system, so you don't have to worry about putting operating systems on it. You don't pay for the license if you don't need to. So it's basically your infrastructure, but you get whatever you want as a service. So technically think of yourself as let me say this, think of yourself in front of a Hyper-V console or a virtual machine management console or a VMware console where you basically go and say, hey, I need to spin up a server. Let's go and put a name, put the operating system you need to, give it some RAM, put whatever hard drive space you need to, click on start, and we'll get started. Essentially the same thing. Much more to it because now when you do IaaS on a cloud, you have to understand what are the resources you're putting in because you're going to be billed for the service you consume, right? So you have to remember that. So these things, SaaS, PaaS, and IaaS, basically constitute your cloud services from what I understand, and everything revolves around these three things, or a combination of these things. So as an organization, you could use something that's using the SaaS, then you are consuming some of PaaS resources, at the same time for certain things you need IaaS. So someone as a developer who's going to do some rapid development and deployment may not need IaaS because it's not going to be just effective. But then someone might need a lot more control on what they're deploying and say like, hey, you know what? This SaaS is basically an offering that someone is providing. It's not going to work for me. So I'm going to do something on my own, and PaaS is not going to be worthwhile for me either because it's not going to give me full control. So I'm going to go IaaS, where I basically have my own virtual machine or my own server and I have full control over it. So obviously, as you go from SaaS to PaaS to IaaS, your workload increases because you are now more and more responsible for things. And as you go upwards, like from IaaS to PaaS to SaaS, in SaaS, you are not responsible for anything except consuming your resources, right? So this is basically all the categories of cloud services that are there. So why does Azure fit in all this? So Azure basically is a cloud offering from Microsoft. So Microsoft's cloud offering is called Microsoft Azure. What would be interesting to know is that Microsoft Azure used to be known as Windows Azure when it first started out. Just quite recently, they changed the name to that. The next interesting thing to know is that they were not the first player in the game. Microsoft was not the first company who came up with this whole cloud thing. Yes, it went through an evolution. Yes, a lot of things happened, but there were vendors before who actually provided this service. When Microsoft came up with their cloud, they did not come with their infrastructure as a service. It was initially offered as PaaS, which is platform as a service. Well, Microsoft obviously had SaaS because they were running Hotmail or Outlook.com right now, what's they're called, and certain services like that. So they were already offering SaaS stuff. But when they came to this whole umbrella of cloud concept, PaaS was something they started with. And they were quite experienced, like I mentioned, that they were experienced in running services such as Hotmail and Bing. So these were cloud services essentially under the cloud terminology right now, having the same characteristics. So it's not something they were doing super new. They knew a little bit of what was going on. The next fact is that they actually have data centers in 17 different regions around the world. So that's where they operate from. I'm not going to say they have 17 data centers. They could have multiple data centers in a region, but it's just 17 different regions in this world they operate from. So which brings you to close proximity from the data centers. So you have a much lower latency and things like that. So for example, I'm from Canada, Ontario. We do not have a data center here. However, the closest for us will be US East Coast 2 or US East. Those will be closer. So if I'm going to spin something up, that's the region I'll choose. Now, if you are in California, which is west coast of USA, or if you're in Asia, then you have Singapore and Hong Kong. You have to determine which region is closer to you and basically run your resources from that region. And they will actually create the virtual machine or the virtual network or the virtual resource in that center that's close to you. This is quite interesting actually, because now that you have your data centers located in different parts of this world, and Microsoft makes it quite easy to move these resources around from one data center to another, a lot of possibilities come out of that. And in the future lessons, we'll see what are the benefits of doing that. But the important thing you have to know is that when you are running your servers, for example, here in USA, that's going to be a little different from how you are going to run your stuff in, for example, in Asia. And when I say it's going to be different, it's not about the technology that's the different thing here. It's about the rules and regulations and compliancy and the kind of data you can put in those countries. Because yes, globalization happened and we are all on board with it, but still the rules and regulations varies from these countries to countries. So these 17 regions might have 17 different operating ways and rules and regulations that you need to know before you actually run that. And we will definitely go into much more details about those in upcoming lessons. So the next thing here is there's a lot of opportunities in cloud, and most large organizations who provide cloud services know that, and Microsoft is no different. So therefore, they have a very high investment in this cloud technology. They're betting quite a bit on this technology, and that's a good thing, which means that that's going to be around for a long time. There's going to be increased competitions. There's going to be a lot more other companies who will come up with different services. It will, now that it's utility, so competition will reduce the price and things will only get better for consumers. That's people like you, me, and other organizations, or from now on, the tenants. So that concludes this introduction to cloud session, and I hope you understood how and why did we come to the cloud and how it helped us and all the disadvantages that were there that we have rounded up into advantageous right now, and cloud works, and maybe it does not work for you. But nevertheless, it's an interesting technology to get in right now, since this is definitely going on the high curve of the graph. So this is something it would be nice to know at this time. So once again, that concludes this video or this session. As usual, our training site URL now is at www.cloudranger.net/Azure-training. You are most likely on the YouTube channel, and if you're not, our YouTube channel is at Cloud Ranger Network. Our Twitter handle is at Cloud Ranger Blog. We are also on Google+, and as usual, if you have any comments or any questions, leave them below in the blog site or on the YouTube comments section. And once again, you can definitely reach me sean@cloudranger.net. If you have any specific questions, I would suggest you put them as comments so others can see, and I'll probably respond sooner if they're on the comments because I check it a couple of times a day. And I would appreciate some comments to understand if you are understanding this properly. One thing I started doing on the blog site is telling you what's the next section or the next video is going to be about. So if you want this to go in a certain way, since I'm building this content right now, it would definitely help. Some things you like, some things you don't like. This is something I'm doing for a very first time, producing these videos. So some comments about how these videos are coming out would be appreciated as well, both positive or negative. And there's a lot of room to fix things. I understand that. And definitely do share. So I hope you have learned something from this video. And I hope you share this around with your colleagues so others can learn this fine technology as well. And I will see you in the next video. Thank you.